there are many different models in Scikit-Learn, and it's useful to know uh, quite a few of these because they all have strengths and weaknesses and can be useful in different settings. So here we will look at a data set on the prices of houses that is available in Scikit-Learn. And actually, we are removing it from Scikit-Learn, so I will need to update this course. So this data set has over 500 data points and 13 attributes. So let us look at those different attributes. We can print the description of the data set. So when we print the description, it tells us information on the different attributes, such as the crime rate of the region where the house is, the proportion of the residential land in the region where the house is, the proportion of businesses where the house is, the number of rooms of the house. And now the challenge is going to be to relate all those features to the price of the house. And the price of the house is stored in the target variable. And here I am looking at the histogram of the target variable. And one thing really stands out, to me at least, on this histogram. And it's the fact that we have a nice price distribution and then it goes up here. And the problem here is that the data is truncated. Any house that was more than $50,000 has been collapsed to $50,000. So this is a bias of the data. And it shows us that it's very important to look at our data to understand its biases. Now, in terms of looking at the data, what I can do is that I can plot the joint distribution of the target that we're trying to predict with each of the features. So this is the price as a function of the crime rate. And you can see that if the crime rate is smaller, the price tends to be higher. I can look at the price as a function of the number of rooms, and you can see that if the number of rooms is larger, the price tends to be larger, which makes sense. So, looking at these distributions, you can see a challenge of this data set, which is that many of the different features have different distributions. There are features of different nature. Here, I have a binary variable that tells me whether the house is next to the river or not. The river is called the Chase River. So I need to combine information of very different nature. And this is often the case in data set that come from sociodemographic databases, for instances. And for this, I will use a specific, I'm going to skip all this. Well, so I can fit the, I can use a linear regression for this. And if I use a linear regression, so I can fit it on the data and I can predict. And this is a plot of the predicted price as a function of the true price. And what you can see is that for the true price, we're undershooting. We are under predicting the true price. And one of the reasons is that this data set is not really linear. And moreover, the notion of linearity on this kind of data is difficult because I, I can't easily build a linear model on features of different nature. It's possible, but it's difficult. So what we can do is that we can use a gradient boosted tree regressor. So a gradient boosted tree regressor is a regressor that is very well suited to data of very different nature. In particular, this kind of data on sociodemographic databases. So a mixture of discrete entities and continuous variables. So gradient boosted trees are very well suited for this, and they are used a lot in the industry for this reason. So they're found in sklearn.ensemble, and I can import sklearn.ensemble.gradient boosting regressor. Okay, and if I do this, I can just replace linear regression in this code, and I can use the gradient boosted regressor. And this shows you one of the strengths of Scikit Learn is that I need to change very little things to be able to swap one model with another one. So in general, if you have data that comes from databases with features of different nature, I would advise to look at gradient boosting, and I would advise to look at the gradient boosting regressor if it's a regression problem, the gradient boosting classifier if it's a classification problem. And we have a new version of these that is faster, that is called the HIST gradient boosting regressor. Let me type this for you because this is very useful. So in the recent versions of Scikit Learn, we have the HIST gradient boosting classifier and HIST gradient boosting. Okay, so I typed this wrong. Well, when I have a problem like this, what can I do? I can Google. And oh yes, thank you, Olivier. Thank you, Loic. Loic is reminding me that I need to import sklearn.experimental. Yes, I need to, well, I need to do this as it explained here. Okay. And now I can import. So as you can see, this is still experimental, but it's going to come out of experimental in the next release. And this is the model that is probably the most useful if your data is made of databases with columns of different nature, which in certain applications is very common. All right. So now that I have this, the question is this useful both for classification and regression? The answer is yes, the HIST gradient. So I have two variants of the HIST gradient boosting. I have the HIST gradient boosting classifier and the HIST gradient boosting regressor. And both are very useful. It's really the nature of the data. If your data is databases, they're very useful. In general, I would probably say that those models are the most useful models of Scikit-Learn these days. If you have reasonably large data, so in the thousands of samples, you can probably try to use them by default.